Hi, my name is Ariel Weaver. I am a former Fulbright scholar that got to conduct research in Namibia in 2017. I'm a graduate of the University of Louisville's Department of Geography and Geosciences. I concentrated on GIS and remote sensing in my research. Today, I'm here to talk about two different subjects. Um, the first will be women in GIS, and the second will be talking about my research that I did while I was in Southern Africa. Um, Happy World GIS Day, happy Geography Awareness Week. Thank you for um, taking the time um, to to listen to me speak about these issues that are very exciting for me. Thank you very much. We're going to be talking about a historical view of women in mapping and cartography. So the earliest known map that it was made by a woman that we know of was created by Inde, a Spanish nun. So, a lot of the scholarship in medieval times um, was predominantly done in abbeys and in monasteries. So it stands to reason that a nun would have would have access to the the education and the resources to create this kind of work. And it's not until the 16th and 17th centuries where women are becoming a lot more engaged in map making process. Women were engravers, colorists, and they would stitch in the leaves of a map into a book, in family run workshops or ateliers. And, you know, uh, moving towards like the end of the 19th century, of one of the first female spatial scientists. This is exciting. Florence Kelly created a series of different maps that uh, showed the relationship between immigration status and poverty in Chicago. And so you really have this, you know, like very slow but, gradual increase in the accessibility for women to be producing cartographic and spatial science kind of work, and I think that's really exciting. So this brings me to the 20th century, 1950s. Marie Tharp was an incredible geologist and cartographer. She studied geology during World War II when the university that she was studying at had they were recruiting women to study because there were not enough male students because they had been drafted for the war. And in the 1950s, she was working at the Lamont Geological Observatory at Columbia University, working with a team that was mapping seafloor depths using sonar. And, it was a very new technology at the time. She was not allowed to board the ships where her colleagues were taking the sonar readings. However, she was landlocked, and she was in the office plotting all of the data that they were recording on the ships. And while she was doing this work, she noticed there were rifts and mountains under the sea, under the ocean, that allowed for her to really prove the idea of plate tectonics, of continental drift. And she initially brought this up to her boss at the time. He later took credit for it a year later. He dismissed her initially as, foolish, of, speaking girl talk or whatever. And he later took credit for her work. this brings me to Gladys Mae West. Gladys was a mathematician, satellite geodesist, programmer, among many other titles you could probably give her, including astronomer. But she was a fascinating woman. She worked incredibly hard. She was extremely brilliant. She was you know, this she started her career at Dahlgren Air Force Base and then was later recruited to work at NASA. She was the second black woman to be hired at NASA. Um, while she was at NASA, she calculated the geodetic models that were used for creating the global positioning system. So in this work, she created a geoid, or, if you don't know what that is, it's a mathematical model of the Earth's surface that accounts for irregularities on the Earth's surface due to various phenomena, including the tides, magnetic forces, gravitational forces, and other phenomena. So this geoid was later used for creating the global positioning system that we use today here in the United States. You know, her work was not well known up until a few years ago when she was interviewed by her sorority in 2017, and it later was publicized that she was one of NASA's hidden figures that that the film was based on. And in 2017, she was inducted to the Air Force Space and Missile Pioneer Hall of Fame, and this was as a result of the publicity that she had received. And it's incredible that someone with such a brilliant mind who made such a great impact, while some of her white male colleagues were receiving accolades for the work that they did, she remained hidden behind the scenes, and the work that she did was incredibly important and allowed for the development of one of the most important technologies that we rely on today in our field. So this brings me to my next topic, conducting field work in Southern Africa. And we'll be talking a little bit about people, the climate, the environment, the wildlife, and also specifically kind of the research work that I did after I got back with the data that I collected while I was. So I'll speak really briefly about Fulbright grants. The Fulbright program was founded by William Fulbright in 1946. He was a senator. He was extremely interested in international relations and fostering international cooperation through teaching, studying, collaboration, and research. This program is sponsored by the U.S. Department of State, and 140 countries around the world are participating, and they have grants for both U.S. citizens and citizens of participating countries. So there's a number of opportunities around the world. Some countries are more competitive than others. Everybody wants to study in Germany or New Zealand. So now I'll talk a little bit more specifically about my research in particular. So my research was, a part of the Kaza region, particular to the Zambezi region. It's a state within Namibia that is central to the larger Kavango-Zambezi Transfrontier Conservation Area that spans through parts of Angola, Botswana, Namibia, Zambia, and Zimbabwe. And it covers over 440,000 square kilometers. The Zambezi region is one of the poorest regions in Namibia, and this is due to political, historical, and geographic issues. And The population is about 91,000 as of 2011, but it's growing. And in 2011, nearly 40% of people were living under the poverty line. The majority of the region um, is over 50,000 people live in rural areas, and those areas are have much higher rates of poverty, such as Congola and Simbinda, where they're up to 58 to 50, 55 to 58% of the population there in each of those towns is under the poverty line. And another thing that I want to mention is that the climate is, becoming more and more unpredictable, in terms of the onset of the rainy season, the duration of the rainy season, as well as the amount of rain that can be received in any given year can range from 200 millimeters to well over 1,000 millimeters per year. The region is also highly dependent on wildlife tourism for economic development, but the majority of people in this region are subsistence farmers, so they rely on corn or growing maize, and uh, and sorghum and millet, but predominantly maize in this region. And so one of the biggest problems, and I might have mentioned this before in an earlier slide, but one of the biggest problems is human wildlife conflict. And this is in terms of, crop raiding by wildlife. Elephants can and do, roam through fields and munch on people's crops, and this can be devastating in terms of the kinds of um, crop yields that people rely on in order to sell at the market, to feed their families, and to live their lives. Another problem, living in close proximity to not just you know like large wildlife like elephants, but also carnivores such as hyenas, lions, and wild dogs. So, for the purpose of this research that I was conducting, um, I was looking at, answering the question, what is the extent of the human footprint in the Zambezi region? And for the purpose of this study, the human footprint refers to the extent of settlement in agricultural areas. And this is so that we could look at how um, settlement and agriculture might overlap particular wildlife dispersal routes, migration patterns, um, and how that might affect, also, um, wildlife migration and wildlife populations in general. The Zambezi region is a major wildlife corridor in the middle of the largest terrestrial transboundary conservation zone in the world, the Kavango Zambezi Transfrontier Conservation Area, also known as CAZA. Um, and I mean, for this region, it's the population has grown rapidly over the last 20 years, and about 10% growth. And at the same time during this period, you see an expansion of built areas, particularly along roadways in linear fashion, instead of more clustered areas. And part of this is due to not enough money going into development of creating enough roads. There's only three main paved roads in the region. All other ancillary roads are, sandy or just straight up dirt roads. And object-based image analysis is one of the methodologies that I use in order to classify the imagery, and I'll talk about the others after this. But object-based image analysis is a method that mimics the way in which humans interpret images through recognizing contextual information such as size, shape, color, hue, and other variables. And you can also use ancillary GIS layers such as shapefiles and DEMs in order to inform the segmentation process, which breaks an image up into image objects. And so these image objects, depending on the parameters that you set in the program that you're using, will create areas of homogeneous, depending on the parameters of size, shape, color, hue, pixel brightness values, other data that you can select in order to break these images up into objects that are of particular size in the image. And this is often used for high resolution imagery, but because of the level of analysis that I was looking at, these larger landscape features such as settlement and agriculture in this region, using Landsat, a more medium scale data set, you can use that to classify image objects, and then do the post classification analysis, so assessing the accuracy, right? Random forest is another approach that I used in my research project. Random forest is a machine learning algorithm where you can use training data collected in the field in order to tune the algorithm to classify land cover classes. And so, to explain this, you have to understand the basic dynamics of a decision tree, where there's a series of questions, and at each node, if does this meet specific requirements? If yes, go this way. If no, go this way. And until you get to a series of final decisions, which would put you in one class or another. And then in terms of the random forest algorithm, it creates a user specified number of trees. Typically about 100 is sufficient, but the algorithm creates these decision trees, and varies depending on the calculations that it does to split the nodes on the questions, like, does it fit within these parameters or these? And if so, go this way or that way. And you get so for each image object or pixel that is being put through the random forest algorithm, it is deciding for in each tree which class. And then so once all of the decision trees have been created, each tree gets a vote for how that image object or pixel is classified, and the class with the majority of votes is selected as that as the final class. And so the best part about this algorithm is that a portion of the training data is set aside um, to be used, is not used in the decision tree creation, and it's set aside in order to do an accuracy assessment. So it's got, and this is called out of bag error in the literature. But and then another thing that is good about this particular algorithm is that it has built-in variable importance estimates that you can use to. So my research questions were, first of all, what is the extent of the human footprint in terms of settlement and agriculture in the Zambezi region? 2, how do object-based random forest and a hybrid approach compare for classification of medium resolution Landsat 8 imagery in a highly heterogeneous environment? So this brings me to the Zambezi region, my study area for my project, and the location map at the bottom right hand corner of the map shows you that over where the red square is where the panhandle of Namibia is, and it's situated in the middle of a number of different countries: Angola, Zambia, Zimbabwe, Botswana, and within this whole area, you've got, within the Zambezi region itself, you've got a number of national parks, and then also conservancies, which are areas, they're communal lands where traditional authorities and local governance structures manage the environment and wildlife in the area. They are the ones that are able to grant permits for hunting or other, and to manage ecotourism in the area. So this brings me to my next slide. This is the larger context of the Kavango-Zambezi Transfrontier Conservation Area. You can see the Zambezi region right there in the middle of it. The Kaza region covers about 440,000 square kilometers. It spans through parts of Namibia, Botswana, Angola, Zambia, and Zimbabwe. And as you can see, it's kind of a patchwork of a variety of different land management strategies and legal designations for conservation. You have national parks, game reserves, conservancies, protected forests, hunting reserves, safari areas, and then you have, areas that are more urban, and others that are very rural. So for my particular project, I was using Landsat imagery in order to calculate the human footprint extent within the Zambezi region, excluding the national park areas. The Landsat image that I used is this Landsat 8 from the optical land imager, and you can see the rows and paths that I acquired. Each of these were pre-processed, and flash calibrated to account for the atmospheric conditions, and then mosaic together into one image. And so this is, and then clipped to the region itself. So this region, this particular Landsat image is a composite of 4 different Landsat tiles, and then clipped down to cover the entire extent of the area. So here is a a view of the three different results for the classifications that I was able to uh, create from the data that I collected in the Zambezi region. So the first one, A, is the object-based image analysis approach. And as you can see, the built area is much larger uh, and less speculative than, the other two. So it's very concentrated, and especially around areas that I would have suspected the built areas to be in, especially towards the central northern area where Katima Malilo is, um, and then along the roadsides, and then B, you have a much larger area that is agriculture, which is also, I think the in each of these there's a difficulty in separating out some of the agricultural areas from the settlement areas. A lot of times they're very close together or interspersed, and there's also the problem of fallow fields and like recently harvested fields looking a lot like the settlement areas. The settlement areas, of course, being mostly bare ground around the settlement area itself, and then fallow or recently harvested field would also like visually look like a bare area as well. And so this can be hard to disentangle in terms of spectral and some of the spatial indicators as well. And then C, this approach has a number of areas that where there is agriculture or built settlement, particularly in the central area that um, I would not suspect. And then under so with each of the different methodologies that I employed, I performed an accuracy assessment. And so when you look at the kappa statistics for each of these, the best performing one was the object-based image analysis approach. And the second best was the hybrid approach, and the worst performing one was the random forest approach. In terms of class accuracy, um, built area within the object-based image analysis approach was much higher at 90%, as opposed to the other two methodologies. And so, a lot of you know, there's still a lot of work that I could do to improve the processing, and perhaps one of the strategies would be to work at this in smaller forms to separate the region into a number of different tiles, and then process each of these separately, and then see how the various methodologies work. I was so lucky to be able to go and build relationships with people that I've been working with online for a number of years, and it was incredibly um, rewarding and a learning experience for me to be able to go build relationships in the communities in the villages where I was doing research to get a much better idea of how people live and how they view wildlife and how they manage wildlife conflict and other issues. I also was fortunate that I was able um, to to not only get to know people managing wildlife at the very local regional level, and then at a much larger international scale, and to interact with those various researchers and government officials and non-governmental organizations in order to really get a full and complete picture of a lot of the different actors and stakeholders in the region. And and also, all of these people help me really get to know the landscape, the vegetation, the wildlife so much more deeply. And that was an incredible experience that I am so grateful that I had, because I can share what I've learned with other people and to really, to support conservation efforts in Africa and here in the United States, like to really broaden people's experience of, how complex conservation can be, especially in such a dynamic and changing environment. And in terms of the geospatial research that I did, I found that the object-based image analysis approach performed much better in accuracy, in terms of defining settlement and agricultural areas as opposed to all other classes. I think that all three methods that I used had some challenges and flaws. I think that the in terms of the way that the object-based image analysis approach goes, you have to spend much more time iteratively testing the variables that you include, and that can be incredibly time consuming and also very frustrating to do. And on the other hand, you've got the random forest approach that, with a moderate level of programming knowledge, you can pretty quickly, load your imagery, and depending on the size of your, imagery and the computing capabilities that you have at your disposal, you can pretty instantaneously produce results. And so, in terms of time and the things that, the other considerations that you have in terms of the amount of data, the amount of accuracy, the other, how complex the environment or the landscape is that you are looking at. I think that each of these methods has their merit and could be, I think I could improve upon the H method in order to improve the results in the future. All three of these methods are still struggling in this particular instance to disentangle overlapping spectral signatures across different land cover types, and some of the other variables that were included in order to separate areas of bare soil from fallow agricultural lands or settlement areas. And part of this is because of the gradients between agriculture and built areas can be difficult to disentangle. They may be appearing in the same they are often interspersed together. There might be some lappas by a field, and they may, like, depending on where the Landsat pixel falls, like a number of these may be mixed pixels. It also may be better to process, tiles of the Landsat mosaic separately, to split the image up into a number of different tiles and then build the decision trees for the object-based image analysis approach, selecting your different variables that you're using in order to create your classifications, and to do that separately. And this might even work better for the random forest approach as well, because I think one of the difficulties is that you have a lot of the misattribution is occurring in the flooded plain areas and areas along the river systems that are there, and to separate those areas from the areas that have much different soil types, and I think might improve the analysis. I also think that you know it may be just too heterogeneous at that level of resolution in terms of Landsat imagery to simplify a classification into purely settlement, agriculture, and other. And then the 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 growth of this region in terms of the human footprint, the fact that the environment is, that rapidly changes due to inputs of rainfall or lack of input of rainfall, and how unpredictable the climate is, can absolutely pose a huge threat to the livelihoods and the health and safety of the people of this region. It's important to not only balance this idea of livelihoods and environmental change, and protecting the environment with balancing the needs for populations, for maintaining healthy wildlife populations, and prioritizing, where to build new settlements, and to start new agricultural areas outside of areas that might fragment wildlife habitats, or block major wildlife corridors, or to reduce human wildlife conflict as well, to maintain enough areas where there are dispersal areas that are safe for wildlife to traverse across in order to get through the Zambezi region off into other parts of the larger Kavango Zambezi Transfrontier Conservation Area. Thank you all for listening to my lecture, and then also have a happy GIS Day and a happy Geography Awareness Week. Thank you very much.